Guys, you're on a peak of the week, and today I selected a special video dedicated to circles which are tangent to each other and they are in a large circle. So here is the picture, actually, that the four smaller identical circles, each of the radius 1 millimeter, are tangent to each other. Those points they're touching, okay, and they're inside a large circle. So here is the big one. You need to find the shaded area that I shade with a pink color, okay, pink stripes. Pause the video, try to do by your own, and let's get started. Okay, so the idea is to find the area by subtraction. So shaded area is simply area of the big circle minus 4 identical areas of each smaller circle. And we definitely know how to work it out. It's pi r squared, whereas the radius actually 1 millimeter. Okay, with this small circle area there is no problem, but however the reason we need to pay attention to the area of the big circle, that's going to be big R squared, the radius of the larger circle, and the main goal is to find R, so big R. Okay, for this reason I just switched to another slide. The target is to find the radius, okay? So that's the target, find the radius of the bigger circle or larger one. And what I'm going to do, using the principle of symmetry, if we split, let's say, if we mark the centers of each circle like that, okay, and we put the line that cuts actually the whole diagram on two equal halves, right? Due to the principle of symmetry, we understand that this line that goes through the center O and also through the centers of the smaller circles, let's say O1 and O2, it cuts your diagram on two equal parts, right? And that's why it's definitely those, let's say point K and point L. So LK is going to be a straight line, okay, straight line. It definitely should be a straight line due to the principle of symmetry, because the top is going to be a half or a semicircle as well as the bottom one. So that's why that's going to be the tangent point, definitely. Okay, so bearing this in mind, we actually can put another lines that will help us soon, okay, from there to the center, and from the center through again the touching point of those two circles to the right corner. Okay, so those points, definitely by definition of two circles being touching in this point, right, or being tangent, those lines are tangent lines. Okay, and that's why they will arrange 90 degrees angle. So this angle in total is going to be 90 degrees. Okay, we simply want to put two radius center O1 here and here. And we definitely know that because they're radius, and also this one as well, oops, and also this one as well, O1K, that's also the radius, we can mark them as small r. So first of all, I just use the general letters R, and in this case, we can arrange right angle triangles, which is also an isosceles. Okay, so radius, big radius, is simply equals to OK segment. Okay, but OK in this way consists of O1 and plus O1K. So O1K, this is the radius of the smaller circle, while O1 is hypotenuse of the right angle triangle. So this triangle is right there, and this is hypotenuse, which can be calculated through the triangles. Okay, let's have a look how it can be done. I just put this triangle nearby, and we simply arrange this triangle separately. So this is O1, hypotenuse in this case. We have an isosceles triangle which is right angle, okay, because radius is perpendicular to the tangent. And we also know that each side of this triangle is r. So that's why, to calculate hype, we need to take the square root of r squared and r squared. So that's why hype is simply r square root of 2. Okay, so that's why OK, which is the radius of the larger circle, is simply, this is hype, right? So that's why it's r square root of 2 plus O1K, which is r. So that's why finally we'll have the equation that connects the smaller radius with the big one. And I just put this formula, not this way. Okay, let's use that one. So I put this as the final formula that connects. So that's why, hopefully, if we just go back and write the radius, which is small 1 plus square root of 2, and we plug into the formula, we'll get the following. So shaded area finally is going to be equal pi r squared, which is small r squared, 1 plus square root of 2 squared, and we're subtracting 4 pi r squared, okay? We just plug r equals 1 millimeter everywhere, so that's why the shaded area in terms of pi is going to be equal. So pi 1 plus square root of 2 squared and minus 4 and pi as the common factor. So actually, if you like, you can simplify, but this is okay. We can consider that as the final expression in terms of pi for the shaded area in millimeters squared. Okay, so that was pretty easier, but you need to draw something. Okay, I can consider this problem as the challenging one, and I'll also offer you a variation of that problem, as if you have the same small circles which are inscribed in their larger circle in this way as it was before. However, you are supposed to find the radius. So the radius of the inner circle, and the inner circle is this small yellow one, okay? So you need to define the radius. So guys, try to do that by your own. If you have any solution to that problem, please share in the comments below to this video. And generally, if you like that, so maybe you can advise me which pick out the week selection for the next week to choose. Okay, just share this information in the comments. If you're new here, please subscribe. Don't forget to smash the bell button, and also visit A-Level Zillion's classes for more information about A-Level stuff. And also don't forget to check my A-Level as well. All right, see you later.